Let's take a look at a fairly straightforward Coulomb's law problem. You're given two charges and a distance and asked to calculate the force. That's the most basic kind of Coulomb's law problem that you can get. So let's start by writing down Coulomb's law, and let's plug in the values. K is always 9 times 10 to the ninth. That's a constant. It's called the Coulombic constant, or Coulomb's law constant. You plug in one of the charges, it doesn't matter which one's Q1 and Q2, and notice two things here. Number one, I've left the negative sign out. Doesn't matter. We'll figure out what direction the force is later on. Just plug in the magnitude of the charge. So if it's -6, plug a positive number in. And remember that micro, that little funny symbol there, means times 10 to the -6. Alright, we're going to do the same thing for the 3 micro coulombs. And we're going to divide by 18 centimeters. Don't divide by 18 though. Divide by 0.18, and don't forget to square it. On your calculator, when you type it in, you're going to use that EE button. It's the second comma. It says EE. Use that. And this is what it would look like on your TI calculator. And you can do it all on one line, all at once. You'll make fewer mistakes. And you hit enter, and you're going to get 5 for an answer. And it's attractive. How do I know it's attractive? How do you know it's attractive? Because they're opposite charges. And of course, it's Paula Abdul physics. Opposites attract. All right, now let's erase that 18 centimeters and draw the direction of the forces. Sure, the negative charge feels a force from the positive charge to the right. The positive 3 is getting pulled to the left because there's a negative charge over here. And the size of those forces are the same, 5 and 5. It makes no difference what the value of the charges are. We're talking forces. And according to Newton's third law, for every action, there's an equal and opposite reaction. And you can see that here in the equation, because it wouldn't matter if we did 3 here and 6 here, or like we have it drawn. It doesn't matter which way you calculate it. It's going to be 5 newtons either way.